Hello, hi everyone. Welcome to the Student the Brand. So this is our Shiva sir. Today topic is light reflection and diffraction. Okay. So in this topic, we will discuss about briefly a reflection of light, regular reflection, irregular reflection, loss of reflection, angle of deviation, and image, object and image will discuss. Okay. So after that, characters of the image formed by the plane mirror. After that, spherical mirrors, concave mirror and convex mirror. After the ray rules of concave mirror, ray rules of convex mirror, image formations by concave mirror and convex mirror. Next, sign conventions. Next, mirror formula. So everything we will discuss. Okay. So after that, we will discuss about refraction, loss of refraction, refraction through the glass slab. After that, lenses, spherical lenses. Okay. So after that, we will discuss about spherical lenses completed. After that, we will discuss about image formations, ray rules and image formations. After that, lens formula, like that it continues. So now we will discuss completely about light reflection and refraction. Light reflection and refraction. Okay. So now you can see reflection. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection is nothing but the bouncing back of the light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so I'm taking the plane surface. So this is a plane surface. This is a plane surface. Okay, incident ray. This is incident ray, and this one is the reflected ray. Incident ray, reflected ray. Okay, and the line which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. Okay, so the angle between incident ray and normal line is called angle of incidence. So the angle between incident ray and normal line is called angle of incidence, and angle between reflected ray and normal line is called angle of reflection. Okay, and the deviated line, so you can observe. So this is the undeviated line. The angle between reflected ray and undeviated line is called angle of deviation. So incident ray, this is the incident ray, and reflected ray, and this one is the normal, and so this one I am taking the undeviated line. So the angle between incident ray and normal line is called angle of incidence, and the angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incidence, and angle between reflected ray and normal line is called angle of reflection. And the line which is perpendicular to the plane surface is called normal lines. Actually that ray is not existed. So for our understanding of, to understand the reflection phenomena, we are drawing with the dotted lines. So actually it is not existed, you can observe here. Okay, so we are drawing with the dotted line. So I hope it is very clear. Okay, so the bouncing back of the light from the reflecting surface, is called reflection of light. Okay, reflecting back of the light from the reflecting surface is called reflection of light. Okay, so incident ray, the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Yes, actually normal line is imaginary line, okay, which is not existed for our understanding. So we are drawing with a dotted line. Okay, so I hope it is very clear. Now, so we will discuss about loss of reflection. loss of reflection. Okay, so loss of reflection. So we can observe loss of reflection. First point is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane, and the angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay, so these are the 2 points. These are the 2 points. Once again, you can observe. So you can observe. So incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. These are 2 points. Okay. Now here you can take this a linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. So that linear angle includes angle of incidence plus angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here you can observe incident ray, reflected ray, normal line lies on the same plane. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line. Okay, so the angle of incidence, reflected, and angle of deviation is 180 degrees. So this line is okay. So this is a linear angle. Linear angle. So it is a linear angle, right? So that's enough. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. So coming to loss of reflection, angle of incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Okay. So from this one, so we can take that is, so we can conclude that from here. Okay. That is angle of incidence plus angle of reflection. Here you can observe angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Correct? So here angle of incidence plus angle of deviation equal to 180 degrees. So now angle of deviation is equal to 180 minus 2 angle of incidence, and angle of deviation equal to 180 minus 2 angle of reflection. So why you are taking this one? Because angle of incident is equal to angle of reflection. So that we can write, instead of angle of reflection, if we write angle of incidence, we'll get this formula. So instead of angle of incidence, if I write angle of reflection, we'll get this formula. Angle of deviation equal to 180 minus 2 angle of reflection. So the bouncing back of the light from the reflecting surface, is called reflection of light. Okay, so incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Now this total is linear angle. So okay, linear angle I am taking. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 degrees. So that's why we are writing angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear. So this is about reflection of light and loss of reflection and angle of deviation. Now we will discuss about regular reflection and irregular reflection. Regular reflection takes place on smooth surface. Okay, regular reflection. So regular reflection. So now we can say regular reflection. Here you can observe I am taking the plane surface. This is a plane surface. Okay, this is a plane surface. So incident light rays are parallel. Incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Okay. Here you can observe these are the incident light rays 1 and 2 and 3 and 4. Okay. These are incident light rays are parallel to each other. Parallel to each other. Then reflector light rays are also parallel to each other. Then this type of reflection is called regular reflection. So here you can observe incident light rays are parallel, then reflector light rays are also parallel to each other. So you can observe this type of reflection is called regular reflection. This type of reflection is called regular reflection. Okay. Now here you can see regular reflection, regular reflection, regular reflection. So regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Regular, you can take example for regular reflection. Plane surface, on plane surface regular reflection takes place. On plane surface regular reflection takes place. And on still water also regular reflection takes place. Coming to irregular reflection, so if any queries you can contact this number. So students, if you need any information regarding notes or anything or classes regarding anything, you can contact to this number. Okay. So I am taking here like this. So this is about what is one irregular surface. Irregular surface I am taking irregular surface. Irregular surface. So incident light rays are parallel. So I am taking these are incident light rays. But reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. So I am taking here like this. You can see. You can observe like this. Okay, so incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Reflector light rays. Okay, incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Example, we can take a wall. Example for a rough surface, wall. Second one is paper. Okay, and paper. So coming to regular reflection, plain mirror we can take. Plain mirror and still water also. Still water. Okay, so I hope it is very clear. So this is about regular reflection and irregular reflection, right? Yes. Now you can see. So I am taking the plane mirror. This is a plane mirror. Okay. So here light rays are coming from the source. So these are the light rays. Incident light ray and this also incident light ray. So after reflection, those light rays are meeting at one point here. Okay. So this is the real image. If you are extending those light rays, extended light rays are meeting at one point. Here you can observe this is the virtual object. Real image and virtual object. And one more thing I am taking here, you can see. one more. So object, so light rays are coming from here. This is the real object. From here I am taking like this, and reflected light rays, and here also. Okay, so we are extending the reflector light rays. Extended reflector light rays are meeting here. This is virtual image. Oh, sorry, virtual image, real object and virtual image. So here, if you observe carefully, this is a real object. Real object and a virtual image. Real image and virtual object. Virtual object. So if you are taking here object and image, object and image, object is real, image is virtual, object is virtual, image is real. Okay, so if you observe carefully here, these are the incident light rays, I1, I2, I1, I2, I1, I2. So this is the R1, R2, and this is virtual object, And here you can observe, this is I1, R1, I2, R2. Okay. Now you can observe whenever the light rays are incidenting on it, after that those are reflector light rays, those are reflecting back. So if you are extending these incident light rays, extended incident light rays are meeting at one point. They are virtual object. Here you can observe this is a virtual object, real image. So the point of intersection of reflector light rays, directly these reflector light rays are meeting at one point, their image is forming, that image is called real image. The point of intersection of reflector light rays is called a real image. The point of intersection of extended incident light rays array is called virtual object. Once again, so the point of intersection of reflector light rays are meeting directly after reflection, light rays are meeting directly, that is the real image. So we are extending the incident light rays. Extended incident light rays are meeting there. That point is called virtual object. And here you can see, so from this point, from one point, incident light rays are coming. So that's what this is a real object. Best example, candle, you can say, like a bulb, like different objects we can consider, different object. From that point, light rays are coming. Okay, so that is a real object. So the source which is giving light, that's why it is called real object. And after reflection, we are extending the reflector light rays. Extended reflector light rays are meeting. Okay, extended reflector light rays are meeting, their virtual image is forming. Extended reflector light rays, reflected ray 1, reflected ray 2. So we are extending these reflector light rays. Extended reflector light rays are meeting at one point, that's why it is called virtual image. Now you can observe this table. Now if you observe this table, okay, whatever I explained till now, so the same points I mentioned here. Okay, I mentioned over here. So whatever the points, so till now I explained. Okay, so till now I explained clearly. Okay, point to point. Same thing I mentioned here. Okay, so object is real, image is virtual. Object is virtual, image is real. Once again, object is real, image is virtual. Object is virtual, image is real. So this is about complete idea of real object, virtual image, virtual object and real image. Now we will discuss about nature of the image formed by the plane mirror, or characteristics of the image formed by the plane mirror. Okay, so let's start here. So I am taking the plane mirror now. So I'm taking this the plane mirror. This is a plane mirror. Okay. Here. So like this I'm taking. So I'm taking the object. Object is here. This is the object. This is the object. Virtual object, that too AB. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays? Minimum 2 light rays are required to form the image of the object. So when light ray is moving along the normal line, so I am taking this a plane mirror. If the light ray is moving along the normal line, so it retraces its original path. Okay, so it bounces back in the same direction. It bounces back in the same direction. It moves in the same direction. Okay, so if the light ray is moving along the normal line, okay, so here also you can see how many light rays are required. So I am taking one light ray here. So incident ray, reflected ray, incident ray, reflected ray, and I am taking one more. So here also I am taking here. So like this. Okay, so after that it's reflecting back. And one more thing I am considering here. So this along the normal line it is moving, and here also this the incident ray, this will be the reflected ray. So we are extending that. You are extending that one. So here you can observe. Like this. So if you are extending the reflected light rays, this is the reflected light ray. Okay, so this is the reflected light ray, and here also reflected light ray, and here I am taking here. Okay, so I hope it is very clear. Like this. Okay, so A, B, and here is A dash and B dash. A dash and B dash, because virtual image is forming. Virtual image is forming. Understood? Virtual image. So in the previous example I mentioned, if the object is real, image is virtual. If the object is virtual, image is real. Right? Yes. First point you can say object is real, image is virtual. Object is virtual, image is real. Coming to the second one, so the distance between, so here, so I am taking this a mirror. This is a mirror, plane mirror. Okay. So this is a plane mirror. This is a mirror. Object, image. Okay, so the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay, so very important. Even for the concave mirror, convex mirror, so in the plane mirror also we will use these points. Okay, distance between object to mirror is called object distance. Distance between mirror to image is called image distance. So object distance is equal to image distance. And third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay, so this is the object height. Okay, height of the object, and this one is the image. Okay, so height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, so magnification is +1. Magnification is +1. So what is magnification? Magnification is nothing but, so the ratio of height of the image by height of the object. Okay. the ratio of height of the image by height of the object is called magnification. Magnification is nothing but magnification. So m equal to plus 1, m equal to magnification is m equal to plus 1. So that is nothing but m is nothing but height of the image by height of the object, that is nothing but minus v by u. Okay, minus v by u. So here you can observe magnification is plus 1. So height of the image by height of the object. Here what type of image is forming in this mirror? What type of image? So virtual erect and same size. Virtual erect and same size of the image is forming here. That's why magnification is plus 1. And coming to the fifth one, it also shows lateral inversion. Lateral inversion. Lateral inversion. Lateral inversion. What is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion is nothing but very simple. So the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Once again, I will explain all the points. Just check once. Object is real, image is virtual. Object is virtual, image is real. Point number 1. And object distance is equal to image distance. Means the distance between object to mirror is called object distance. Okay. So the distance between object to mirror is called object distance, and the distance between mirror to image. The distance between mirror to image is called image distance. So object distance is equal to image distance. And next one, height of the object is equal to height of the image. So this is the object height and this is the height of the image. Height of the object is equal to height of the image, and magnification is plus 1. So what is magnification? Magnification is nothing but the ratio of height of the image by height of the object. Simply we can say height of the image by height of the object is called magnification. Okay. So our size of the image by size of the object. So instead of we can take height, so we can take size also. Size of the image by size of the object is called magnification. And coming to lateral inversion. So what is lateral inversion? So if you are standing in front of the mirror, if you lift your right hand, it appears in the left side of the image. If you lift your right hand, okay, so object right hand appears in the image left side. So object left side appears, object left hand side, okay, appears in the right side of the image. Okay, so simply we can say right side of the object appears in the left side of the image, left side of the object appears in the right side of the image. That image conversion is called, or this mirror image is called lateral inversion. This mirror image is called lateral inversion. Simply we can say right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. I hope it is very clear. So this is about characteristics of the image formed by the plane mirror, or simply we can say nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So I hope you got it. So this is about the concept, and now we will discuss about spherical mirrors. Okay, let's discuss about spherical mirrors. So the mirror which is in the form of curved shape is called spherical mirror. The mirror which is in the form of curved shape. The mirror which in the form of curved shape is called spherical mirror. There are two types of spherical mirrors are there. One is concave mirror and the one is convex mirror. The mirror which whose reflection takes place inward. Okay, spherical mirror. One is concave mirror. Spherical mirror. The mirror which is in the form of curved shape is called spherical mirror. Spherical mirrors are two types. One is concave mirror, and the second one is convex mirror. convex mirror, convex mirror, concave mirror, okay, concave mirror. So here I am taking this the concave mirror, concave mirror I am considering like this. Okay, so if you are it is a part of the sphere actually. So you are taking this sphere, a small portion if you are considering, a small portion is considering the concave mirror, concave mirror. So here I am taking like this, here I am considering after reflection, this is a concave mirror. So I am explaining about concave mirror, concave mirror. So whenever light rays are incidenting on it, whenever light rays are incidenting on it, after reflection, so these are light rays. After reflection, those light rays are moving towards the principal axis. After reflection, those light rays are moving, are coming closer to the principal axis. So this type of mirror is known as concave mirror. Concave mirror is also known as converging mirror. Converging mirror. Okay, so coming closer. Light rays after reflection, light rays are moving towards the principal axis, are reaching towards the principal axis, are coming closer to the principal axis. That's why it is called concave mirror. Okay, reflection takes place inward and coating will be outward. Okay, so that is about concave mirror. Coming to the convex mirror is also known as diverging mirror. So why we are calling convex mirror is a diverging mirror? Whenever light rays are incidenting on it, okay, so here I am drawing convex mirror. This is the convex mirror, convex mirror. It is a part of the sphere actually. So it is a part of the sphere like this, part of the sphere. So I am taking here, this is a part of the sphere like this. If you take a small portion, I am taking a small portion, that's why it is called a concave mirror, concave mirror. Now, so just I am considering here, this is the convex mirror, this is the convex mirror, convex mirror. Okay, so it is a part of the sphere like this. So it is a part of the sphere. So principal axis, when light rays are incidenting on it, when light rays are incidenting on it, okay, so after reflection those light rays are moving away from it. So here you can observe those light rays are moving away from it, so like this. Okay, so we can extend, if you extend those light rays, so after extending the reflector light rays are meeting at one point, reflector light rays are meeting at one point. So this is the convex mirror, convex mirror. Okay, convex mirror is also known as diverging mirror, diverging mirror. So you can see convex mirror is also known as diverging mirror. Sir, why you are calling convex mirror as a diverging mirror? So why, whenever light rays are incidenting on it, so you can observe whenever light rays are incidenting on it, those light rays, those reflector light rays are moving away from the principal axis. This is the principal axis. So after reflection, those light rays are moving away from the principal axis. That's why it is called diverging mirror. Okay, light rays are moving towards the principal axis, then it is called converging mirror. But here what is happening, after reflection light rays are moving away from the principal axis, light rays are moving away from the principal axis, that's why it is called diverging mirror, diverging mirror. Okay, so now we will discuss about terms related to spherical mirror, terms related to spherical mirror. Okay, so now you can see here terms related to spherical mirror. So as I said, so I am taking the concave mirror, it is a part of the sphere, I mentioned very clearly. So it is a part of the sphere. So here you can observe like this, here you can observe like this. So part of the sphere I mentioned. Okay, so here I am taking like this, it's a part of the sphere. So like this, concave mirror. Okay, so now you can observe this is the center of the imaginary sphere, center of the imaginary sphere in which mirror is a part. So actually it is a concave mirror. This is a concave mirror. Concave mirror means reflecting surface will be inward, quoted will be outward. So this is the concave mirror. And the midpointer, so center of the imaginary sphere, center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. First point is center of curvature. Second point is midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. Okay, so third one is principal axis, principal axis, principal axis. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So I am taking this the distance. The distance between center of curvature to pole is called radius of curvature. This is the radius of curvature. Okay, after reflection all light rays are meeting at one point. So I am taking here, these are the incident light rays, this is also incident light rays. After reflection those light rays are meeting at one point. Okay, so here I am taking this is so focus. So capital F we will denote with the capital F, capital F. Okay, so fourth one is capital F, and fifth one is the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So this distance is called focal length, will denote with a small letter F. And the sixth one, width of the mirror is called aperture, where reflecting surface, okay, where light rays are reflecting. So this width is called what is that? Aperture. Okay, width of the mirror is called aperture, where where light rays are reflecting. Okay, so that width is called, or diameter of the reflecting surface is called aperture. So center of curvature, pole, principal axis, focus, focal length, and radius of curvature. So seventh one is radius of curvature. Radius of curvature is nothing but the distance between center to pole. Okay, radius of curvature. Radius of curvature. Once again, observe all the points. So observe carefully here. So check once, you will get it. Okay, so here you can see point number 1, center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere. Okay, so I am taking this so entire sphere. So we are taking the small portion. Center of the imaginary sphere in which mirror is a part. Okay, that is called center of curvature. The midpoint of the mirror is called pole, and the line joining of center of curvature and pole is called principal axis. And after reflection, so these are the incident light rays. So after reflection, so I1, I2, R1, R2. Okay, so if you want, I'll briefly mention here I1, this is R1, I2, and R2. So here you can observe. So I1, I2, and R1, R2, these reflector light rays are meeting at one point. So reflector R1, R2 are meeting at one point on the principal axis. So the line joining of center of curvature and pole is called principal axis. Okay. So these reflector light rays are meeting at one point on the principal axis, that is called focus. So generally we can say principal focus, simply we can say focus. Actually it is principal focus, but we can say generally focus. Okay, and distance between focus to pole is called focal length. Distance between focus to pole is called focal length. And width of the mirror, so this is the width of the mirror, this mirror width is called aperture. Diameter of the reflecting surface, diameter of the reflecting surface is called aperture, diameter of the reflecting surface. And the distance between center of curvature to pole is called The distance between center of curvature to pole is called radius of curvature. Okay, so do like, share and subscribe to Student the Brand. Please click on like button. Okay, so share to your friends, share to your, okay, so in all groups, so let them know live class is going on. Ask them to join to the class because important concepts are going on, okay, related to light reflection, refraction, CBSE Grade-10 physics. So now till now I explained about terms related to spherical mirror. Till now I explained about terms related to spherical mirror. Next I will explain about ray rules of concave mirror and convex mirror. So please click on like button. So thank you so much for joining. So please click on like button, share to your friends, share your groups, all groups. Okay, so let them know your live class is going on. Siva sir is teaching physics. That too light reflection and refraction, CBSE Grade-10 physics. So thank you so much. Please click on like button, subscribe my channel if you're new to the channel. So already subscribed. Thank you so much. Okay, now so we are going to discuss about ray rules. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. So now let's discuss about it. Concave mirror. Ray rules of concave mirror. Ray rules. So ray rules will discuss for both mirror, concave and convex. So because similar ones only it will be. So concave mirror, first one. So every time pole, focus, center of curvature. Every time you are drawing the mirror, you must mention this point. So one light ray coming from infinity after reflection passes through focus, and coming to the second one here, pole, focus, center of curvature, light ray is passing through focus. After reflection it moves towards infinity, and coming to third one, light ray is passing through center of curvature. So pole, focus, center of curvature, light ray is passing through center of curvature. After reflection it retraces its original path, and coming to the fourth one, so here you can observe. So pole, focus, center of curvature, light ray is incidentally at the pole. Okay, so after reflection it reflect back into the same medium. Concave mirror, so here you can observe light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Here light ray is incident the pole, it reflects back. Okay, so now you can take, so this is the concave mirror. Next one we will discuss about convex mirror. Concave mirror. Next one, convex mirror. So first one, convex mirror I am taking here like this. So pole, focus, center of curvature, pole, focus and center of curvature. So light ray is coming from infinity, after reflection it moves away from the normal line, so it is passing through focus, first point. And coming to the second one, now here, so pole, this is a pole, focus, center of curvature. Light ray is passing through focus like this. Okay, like this. So it passes through focus. After reflection, it moves. And coming to third one. So here you can observe pole, focus, center of curvature, pole, focus and center of curvature. Light ray is passing through center of curvature. So it retraces its original path, light rays. And coming to the fourth one. So here you can observe pole, focus, center of curvature, pole, focus and center of curvature. Light ray is incidenting at the pole. Light ray is incidenting at the pole. After reflection, it moves. Okay, it reflects back into the same medium. Okay, so I hope it is very clear. Just check once. So concave mirror and convex mirror, concave mirror and convex mirror. So ray rules of concave mirror and ray rules of convex mirror, similar ones only it will be. So like this, light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Light ray is incidenting at the pole, it reflects back. And for convex mirror also same thing. Light ray is coming from infinity, after reflection, so it bounces back, it passes through focus. So light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. After reflection, light ray is incident at the pole, it reflects back. Okay, so these are the ray rules of concave mirror and convex mirror. So now we will discuss about image formations. Image formations of concave mirror and convex mirror. Image formations. Image formations of convex mirror and concave mirror. Image formations. So let's discuss image formations. So first one, concave mirror. So I am taking the concave mirror like this. So pole, focus and center of curvature. Object is placed at infinity. Object is placed at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I am taking one light ray like this. So another light ray I am taking like here. Okay, after reflection, those are meeting at one point. So where? At focus. Okay, so here you can observe after reflection, these light rays are meeting at one point. Okay, so this is the focus. Object is at infinity, image is formed at focus, nature of the image is real and inverted, and size of the image is highly diminished. So first one. Coming to the second one, so concave mirror I am taking here. So pole, focus and center of curvature, pole, focus and center of curvature. Object is placed beyond center of curvature. So now I am placing the object here. Object is placed here. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Okay, so one light ray I am taking like this. So here I am taking here. And here, so it passes through focus like here. So it passes through focus. Another light ray is passing through center of curvature. Okay, so the image will form between C and F. So here image will form like here. Okay, object is placed beyond center of curvature. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted, and size of the image is diminished. Compared to the object, image size is decreased. And coming to the next one, so third one, so here you can observe third one. So pole, focus, center of curvature, object is placed at C, image also will form at C. Okay, so image also will, how many light rays? One light ray I am taking like this, it passes through focus. One light ray. Okay, so another light I am taking like here. So pole. So those light rays will meet. Here you can observe those light rays will meet here. So object is placed at C. Object is placed at C. Image also will form at C. Object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Same size because so wherever object is placed, image also will formed at that point only. So that's why object is at C, image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Coming to the fourth one. So object is placed between C and F. So object is placed here. How many light rays are required to form the image of the object? Minimum 2 light rays, as I said. So one light ray I am taking like this. So after reflection passes through focus. Okay, another light ray is incidentting at the pole. So it will be reflected. Okay, so these light rays will meet here. So object is placed between C and F. Image is formed beyond center of curvature. Object is placed between C and F. Image is formed beyond C. Nature of the image is real and inverted. And size of the image is enlarged. Compared to the object, image size is increased. And coming to the fifth one. So pole, focus and center of curvature. Pole, focus and center of curvature. Object is placed at F. So one light ray I am taking like this. Object is placed at F. So after reflection passes through focus. So another light ray is incidenting at the pole. It reflects back. So object is at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Okay. So now coming to the sixth one. You can see. So object is placed. So P, F, center of curvature. Object is placed between P and F. Okay, how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. After reflection passes through focus. Another light ray is incidenting at the pole. It reflects back. So if you are extending these light rays, Okay, if you are extending these light rays, so like here I am taking like this. Okay, those light rays are meeting behind the mirror. Behind the mirror. Okay, object is placed between F and P. Image is formed behind the mirror. Behind the behind the mirror. Behind the mirror. Nature of the image is virtual erect. Actually, here this is very important for 3 marks question. So applications are there. Okay, shaving mirror, and so we will get virtual erect and enlarged. Virtual erect and enlarged image will form in this case. Okay, so be careful. So very important question. So object is placed between F and P. Image is formed behind the mirror. Nature of the image is virtual and erect, and size of the image is enlarged. Size is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. So this is about so this is about okay, so rare image formations of concave mirror, image formations of concave mirror. Okay, done. So now we will discuss about convex mirror. Convex mirror. So in concave mirror, so hi, hello everyone, welcome to the class. So please do like, share and subscribe to Student the Brand. If you like the content, if you like the explanation, if you like the channel, please share to your friends, ask your friends to join and share as much as possible to your okay, so known friends, and in groups also ask them to join. If you like the content, if you like the explanation, please do like, share and subscribe to Student the Brand. Okay, so click on like button, so it will be helpful me to reach maximum students. Okay, thank you. So now convex mirror, so concave mirror already completed. Now we will take convex mirror. So convex mirror, so pole, so this is the pole, focus, center of curvature, pole focus and center of curvature. Okay, one light ray I am taking like this, so another light ray I am taking like this. After reflection, so here you can observe, if you are extending these light rays are meeting at one point on the principal axis, so that is focus. Object is at infinity, image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. Sorry, virtual erect. Here, so in convex mirror we will get virtual erect. Convex mirror, virtual and erect. Virtual object is at infinity, image is formed at focus. So what type of image will form? Virtual erect, and the nature of the image is highly diminished because point size image will form. And coming to the next one, so pole, subpole, focus, center of curvature, pole focus and center of curvature. So I am taking object is placed between infinity and optic center. So one light ray I am taking like this. So here another light ray I am taking, object is incidented. So here. So if you are extending these light rays, so I am extending here like this, like here, and so here if you are considering, so the image will form here, the image will form between P and F. Object is placed between P and infinity. Image is formed between P and F. Nature of the image is virtual erect. nature of the image is virtual erect, and size of the image is so diminished. So size of the image is diminished because image size is decreased, diminished. Okay, so I hope it is very clear. So point 1 and 2, 1 2. Okay, so this is about hi, hello, welcome to the class. Next, sign conventions. New Cartesian, sign convention, new Cartesian, sign convention. All distance are measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention. So in the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive, and below the principal axis, all are negative. So what are those? Object distance and image distance. Okay, object distance, image distance, focal length and radius of curvature. Okay, so object distance, image distance, focal length and radius of curvature, all are positive along the incident rays direction. Okay, so in this direction all are positive. So opposite to incident rays all are negative. Above the principal axis all are positive, below the principal axis all are negative. Once again, all measurements will be taken from the pole. In the direction of incident rays all are positive, opposite incident rays all are negative. Above the principal axis positive and below the principal axis negative. Okay, so this is about sign conventions, and next we will discuss about mirror formula. Okay, mirror formula, mirror formula, 1 by f equal to 1 by v plus 1 by u. Point number 1. Point number 2, magnification equal to height of the image by height of the object is nothing but so minus v by u. So minus v by u. Magnification is nothing but height of the image by height of the object. Okay, so 1 by f equal to 1 by v plus 1 by u, that is a mirror formula, and magnification is nothing but the ratio of height of the image by height of the object is equal to minus v by u. Okay, that is about magnification. So this is about concave mirror, convex mirror. So right from starting onwards what we discussed. So from starting onwards, first reflection of light, the bouncing back of the light from the reflecting surface is called reflection of light, and incident ray, reflected ray, normal line. So loss of reflection, angle of incidence is equal to angle of reflection, and angle of deviation 180 minus 180 angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of reflection. So and next one we discussed about regular reflection, irregular reflection. So regular reflection takes place on smooth surface, irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface, irregular reflection takes place on rough surface. So regular reflection example we can take plane mirror, still water. Regular reflection, that is plane mirror and still water. Irregular reflection takes place on rough surface, wall, everything. And after that we discussed about object and image, and nature of the image formed by the plane mirror. Okay, after that concave mirror, convex mirror, and next one we discussed about terms related to spherical mirror, ray rules of concave mirror and convex mirror. After that, image formations of concave mirror and convex mirror. Next one, terms related to spherical mirror. Next one, mirror formula. After that, magnification. Okay, so these are points we discussed till now. So thank you so much for joining and attending and listening my class. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student the Brand. Inform to your friends, ask them to join to the class. So share the live class to everyone. So ask them to join to the class. So thank you so much for joining and attending and listening my class. So if you like the content, please support my channel. Please support the channel, so by liking, sharing and subscribing. Okay, so this is your Siva sir from Student the Brand. So I'll continue my work, okay, to support the students. Thank you so much. This is your Siva sir. We'll see you in the next class.